Here we are for another video. This video is indefinite integrals. So let's go ahead and get started. Now I do have the problems written out, but after I wrote the problems out, I realized I wanted to work an additional problem. So I'll add another problem after we work the last one. All right, so let's look at this. We'll come back up to this part here later. All right, it says indefinite integral. So we've got the integral of f of x dx is equal to capital F of x plus c. All right, f of x is called the integrand. Capital F of x plus c is the indefinite integral. C is an arbitrary constant, and this is your integral sign. All right, now, if you watched the last video, we did antiderivatives, but we kind of made we went through the process of, okay, what function can I take the derivative of to get this? Okay, we didn't really have any formulas or anything like that, but this section we're gonna see some formulas. Now notice this right here, this plus c. You're going to always add this plus c when you do the integral or find the antiderivative. It's plus some constant. Now, what is that constant? Well, we don't know, because in some of most of the problems in this section, they're not going to give us enough information to figure out what c is. But I think there's one example where we will be able to find c, and then as we move on in the course, we'll work some applications where we will be able to figure out what c is. All right, so and here's the where it may make a little more sense on this arbitrary constant c. So if you notice, if we take the derivative of each one of these functions here, okay, I've got 1, 2, 3, 4 functions here. What's the derivative of each of these? They're all 3x squared. They all have the same derivative, and that's because what's the derivative of a constant? It's 0. See, the derivative of 4 is 0. The derivative of -7 is 0. The derivative of 4 pi is 0. Do not forget to put the plus c. I have graded tests where, I may have 8 or 9 problems that they have to integrate, and they'll integrate them right. They'll get the correct antiderivative, but on every one of them they forget that plus c, and it's -1 each time they do that. So they get all the problems right, but if it's 9 problems, that's 9 points they're missing because the student didn't put plus c. So don't forget to do that. All right, so let's look at this. This right here, we have the integral of a. A is constant. It's a constant. So anytime you take the antiderivative of a constant, it's just the constant times whatever your variable is. That's this du. It may be du, dx, dt, whatever. That tells you what your variable is. So it's just the constant times the variable plus the arbitrary constant c. This right here tells us that if we have several terms, that we can just integrate each term individually, and of course plus c at the end. And look at this, I left off the plus c right there. And then this one is if we have a variable raised to a power. Okay, I know this is u to the n. Most of the time you're going to see x to a power or t to a power, something like that. You can see theta to a power, r to a power, okay? But the thing is, it's a variable raised to a power. Well, how do you find the antiderivative of that? Well, you just add 1 to the exponent, see that? and then you multiply by the reciprocal of the new exponent, and then plus your constant c. Okay, and this is, and also we need to put here, this is where n is not equal to -1. Okay, that's later on in the course when n is -1. All right, so let's start working some examples. But the main thing that you've got to remember is this right here. The only thing we know how to integrate is x raised to a power, or a variable, some variable raised to a power. And that exponent, n, is a number. All right, so let's look at this. So what do we get here? Yeah, we've got a number out in front here, but that's going to be 5. Okay, the 5 just comes along. And now what do we do here? We add 1 to the exponent, so that's going to be x to the 5th, and then we multiply by the reciprocal of the new exponent. Okay. Now keep in mind when you have this number in front here, this 5, it's just kind of like that 5 is tagging along with it. Okay. So I'm looking at this part right here. I add 1, that gives me a 5, and then I multiply by the reciprocal of our new exponent, which is the reciprocal of 5 is 1/5, and then plus c. And so this would give us 5 times 1/5 is 1, so that's just x to the 5th plus c. Okay. Now I hope the number in front here is not confusing you. So let's just look at a quick example here at x cubed dx. All right, so what do we do here? We add 1 to the exponent. You see that? Add 1 to the exponent, and then multiply by the reciprocal of your new exponent, which is 1/4. And so that would be your answer. Okay, if you have a number in front, the number just kind of tags along with it. All right, let's look at this example. So this is x, and I'm going to add 1 to the exponent. So remember, this exponent's understood to be 1, so 1 plus 1 is 2. Let's go ahead and write our 6 there. And then what's the reciprocal of the new exponent? It's 1/2 and plus c. And so that's 3x squared plus c. Okay? All right, let's look at the next problem. All right. So we just integrate each term individually. Okay, so I'm going to add 1 to the exponent, which is 4, multiply by the reciprocal of your new exponent. Okay, so that takes care of the first term, minus, now let's look at this term. Let's write the 6 down, add 1 to the exponent, multiply by the reciprocal of the new exponent, and then plus, what's the antiderivative of 1? Remember, 1 is a constant, and what's the antiderivative of a constant? It's just the constant times the variable. And so that's going to be 1 times x, and then that's plus c. And then we'll clean it up a little bit. So that's going to be 5/4 x to the 4th minus 2x cubed plus x plus c. And there's your answer. All right. All right, so what about this one? Well, look at this one. This one looks nothing like our formula. Remember, the only thing that we know how to integrate is a variable raised to a power. That's it. It needs to be in this form, u to the n. And we don't have that. Here we have square root. Now, in this, and also in this problem, our variable is r, okay? Which you work at the same, it's just the variable's r instead of x, or u, okay? All right. So the first thing that we're going to need to do is we need to make these two terms look like this. And so we need to rewrite the problem. So let's see, we got square root, but isn't that 1/2 power? You see that? We're just rewriting the square root in exponential form. And then this one, yes, we've got r raised to a power, but it's in the denominator. Our formula, it's not in the denominator. So what do? We just move it across the fraction bar. That's minus. And what happens when we move it across the fraction bar? It changes the sign of the exponent. And so now we have it, the variable raised to a power, variable raised to a power. And so what do? Well, we add 1 to the exponent. So 1/2 plus 1 is 3/2. And then multiply by the reciprocal of your new exponent, which is 2/3, minus, writing the minus sign down. And then I've got r, and I got to add 1. So -3 plus 1 is -2. And then multiply by the reciprocal of the new exponent. So times -1/2, and that's plus c. And so we clean it up a little bit. So that's 2/3 r to the 3/2. A negative and a negative is a positive, and that's going to be, now let's just go ahead and put an extra step in here. That's r to the -2 plus c. Now keep in mind, we're going to rewrite it again. Now, this exponent's negative. Let's make it positive. Do you remember how to do that? Well, if you look at it as a fraction, remember when you move it across the fraction bar, it changes the sign of the exponent. So this r to the -2, we're going to move it across the fraction bar. And so that's going to be 1 over 2r squared plus c. Now, this step right here, what I wrote here, you don't have to show that. You can go from here to here, okay? I just put this in on this problem. I probably won't show this step anymore, but, I just did it this first time so you could see it. All right? All right, so those are pretty basic problems. You got a variable raised to an exponent. You just add 1 to the power and then multiply by the reciprocal of the new exponent. Okay? All right. Now let's look at this. All right. So here we have x squared plus 1. That's all in parentheses raised to the third times 2x dx. Now, this looks nothing like our problem. Our formula looks nothing like it. I don't have a variable raised to a power. I mean, I do right here, but it's all in parentheses raised to a power. Okay? Now, I've had students write this out as x squared plus 1 times x squared plus 1 times x squared plus 1. Multiply this out, get an answer, and then multiply it to that, get an answer, and then distribute that 2x, and then integrate each term. You don't want to do that. On this problem, could you do it? Yeah, probably so, because it's just a cubed. But what if your teacher puts an exponent on here, say the exponent's 50? You're not going to multiply all that out. So how in the world do we integrate something like this? And keep in mind, we need it in this form. That's the form we need it in. Variable raised to a power. So what we do here is we're going to do u-substitution. This is very important that you learn to do this u-substitution. Okay? You're going to use it a lot with integrals. All right. So typically what we do is we look inside the parentheses. Okay, look inside the parentheses right here. And what I like to do, I like to just do a quick little check. So if I look at this inside the parentheses, what's the derivative of this? Well, the derivative of x squared plus 1 is 2x. Do you see how I have a 2x out here? Okay, that's a good thing, that it matches. So we can do u-substitution. So what I'm going to do is I'm going to let u equal x squared plus 1. And then I'm going to do the differential. So du is equal to 2x dx. Remember the section you did on differentials? Okay, that was in a previous video. Okay, that's all we're doing. All right, now what I'm going to do is I'm going to make substitutions here. In the place of x squared plus 1, I'm going to substitute in u. You see that? And then, look at this. See the 2x dx? The 2x dx, I'm going to replace that with du. You see that? So I'm going to get the integral of u cubed. See the x squared plus 1. That's going to be replaced with u. And then look at this. The 2x dx. Well, there's 2x dx. I'm going to replace it with du. And now look at that. It matches this. Now I can just use this power rule to find the antiderivative. And so I'm going to add 1 to the exponent and then multiply by the reciprocal of the new exponent and plus c. Now, we're not done just yet. Our original problem is in terms of x. So we've got to get this back in terms of x. And so I'm going to get 1/4. Now I've got u to the 4th. Well, what is u? Well, u is x squared plus 1. So that's going to be x squared plus 1 to the 4th plus c. See, all I did here is I took the x squared plus 1 and I plugged it back in for u. And so this is my answer. All right, so let's do another one. All right, so how about this one? Well, remember what we just talked about in the previous problem, that this looks nothing like our formula u to the n. Looks nothing like it. And the other thing we talked about up here is if we have something in parentheses raised to a power. What did I do? I looked inside the parentheses and said, okay, what's the derivative of that? And the derivative of this was out here. You see that? So maybe we do the same thing with this one. But you might be thinking, well, you don't have something in parentheses raised to a power. But, you know, when you think about it, we do have x squared. Oh, look at that. That's the square root. So that's x cubed plus 2 to the 1/2 dx. Okay? Now, what did we do on the last problem? We looked inside the parentheses and took the derivative of that. Well, what's the derivative of this? It's 3x squared, right? Uh-oh, we got a problem, don't we? The derivative of this is 3x squared, but I have x squared. I don't have 3x squared. But it's really not that big of a deal because the variables match. Let's write it down. I'm going to let u equal what's inside the parentheses here, which is x cubed plus 2. And so du is 3x squared dx. Okay? So obviously here, let's do this. here, this is going to be replaced with u because it matches perfect. But let's look at this. I've got x squared dx. And look at this. There's x squared dx. I'm missing the 3. You see that? It would be real nice if I had a 3 right here. And then it would match exactly, and then I could replace all of that with du. But I don't have the 3. I need a 3. Well, let's see. Since we need the 3, how about we just add the 3? Let's just multiply by 3. And now, look at this. It all matches. And so all of this underlined in red, I can replace with du. But you might be thinking, well, you can't do that. You can't just multiply the problem by 3. It changes the problem up. And you would be correct. Okay? We can't just multiply by 3 because it does. It changes the problem. So let me ask you this. What's the only number we can multiply to something and get the same thing back? That's 1, right? 1 times anything, you get the same thing back, right? So how about instead of multiplying by 3, I multiply by 1? So I multiplied by 3, and so what if I come out here and multiply by 1/3? What's 1/3 times 3? Let's see, 1/3 times 3. Oh, that's equal to 1. So I actually multiplied that problem by 1, didn't I? You see that? So why did I multiply by 3? So the x squared dx, so I needed the 3, so I multiplied by 3 so it would match this. But then I go outside the integral and multiply by 1/3. Now, the other thing I want you to keep in mind is if you have an integral, and let's just write this down. If you have an integral, if you have cu du, our variable is u, c is our constant. That's the same thing as c times u du. You can pull a constant out of the integral. And that's all I did. I mean, I could have come in here and multiplied by 1/3. Okay, but I don't need the 1/3 in there. I just need the 3. So that's why, so then I just say, okay, well, I'm going to pull the 1/3 out. So now I'm really multiplying by 1. Okay, so now let's make our substitutions. So I've got 1/3 times the integral. Now the x cubed plus 2, I'm going to replace that with u, and that's u to the 1/2. And then the 3x squared dx. You see all that? The 3x squared dx. Well, what is 3x squared dx? 3x squared dx is du. And so that's times du. And now I'm ready to integrate. See, I've got u raised to a power. And so let's write the 1/3 down. So that's going to be u add 1. So that's going to be 1/2 plus 1 is 3/2. Multiply by the reciprocal of the new exponent, which is 2/3 plus c. And so this is going to be 2/9. And then in the place of u, I got to get it back in terms of x. So in the place of u, I'm going to plug the x cubed plus 2 back in. Plus c. All right. And that's your answer right there. All right, so let's look at this problem. I don't know. Okay, so we got 2 more plus the 1 I want to add. All right, so this example, it says find y in terms of x, given dy dx is equal to 3x minus 1, and the curve passes through 1, 4. All right, so we've got dy dx is equal to 3x minus 1. And so that's going to be dy is equal to 3x minus 1 times dx. Now, what do I need? I need to know what y is. It says find y in terms of x. So I'm going to integrate both sides. Okay. All right. So the antiderivative of dy is y. Okay. So over here our variable is y because it's dy here. Over here our variable is x. All right. So this is like 1 times dy. So what's the antiderivative of 1? 1 times x, which is, 1 times y, which is just y. And then that's going to equal, now here, that's 3x minus 1, so I just integrate each term individually. This is not a u-substitution here. There's no exponent out here on the parentheses. I mean, it's understood to be a 1, but, you know, that's fine. It's a 1. It's not a 2 or a 3 or a 1/2 or a 3/2. Okay? So the antiderivative of 3x, that's going to be, there's the 3, add 1 to the exponent, and then multiply by the reciprocal, minus, and then the antiderivative of 1 is x plus c. And so I get y equals 3/2 x squared minus x plus c. All right, now let's look at this. It tells us the curve passes through the point 1, 4. So what this is going to do, well, this is going to let me solve for c because I know what x is and I know what y is. I've got an x value and I've got a y value. So I can figure out what c is. I'm going to take the 4, plug it in for y, and take the 1, plug it in for x. So that's 4 equals 3/2 times 1 squared minus 1 plus c. And now I just solve for c. And so that's 4 equals 3/2 minus 1 plus c, which, let's see, 4 equals, 3/2 minus 1 is 1/2 plus c. And so c is equal to 4 minus 1/2 is 7/2. So this gives me c is equal to 7/2. And so remember, this is what I got after I integrated. So I'm going to take the 7/2, plug it in for c. So I get y equals 3/2 x squared minus x plus 7/2. And there's my answer. So that's why you put the constant, because sometimes they may give you enough information to figure out what c is. And in this case they did. It was 7/2. All right, so let's look at this one. It says the time rate of change of the displacement velocity. Remember, that's the derivative is a rate of change of a robot arm is ds dt is equal to t times 9 minus t squared. Find the expression for the displacement as a function of time if s equals 0 centimeters when t equals 0 seconds. All right, so they want us to find the displacement function. So if you remember back when you did derivatives, if you had a displacement function, you could take the derivative of that and that would give you the velocity function. And then remember, you could take the derivative of the velocity and that would give you acceleration. Well, we've got velocity and we want the displacement. So we just find the antiderivative of the velocity function. Okay, so I've got ds dt is equal to t times the square root of 9 minus t, I'll put an x, t squared. And so ds dt, so ds is equal to t times the square root of 9 minus t squared dt. And so let's integrate. So we got the integral ds equals the integral t. Now, remember, that's a square root, but I want to see it in parentheses raised to a power. So I'm going to write it as 9 minus t squared raised to the 1/2 dt. And so this is going to give me s is equal to, all right, so here we need to use u-substitution. So I'm going to let u equal what's inside the parentheses. So that's 9 minus t squared. And so du is negative 2t dt. All right, so let's look at this. I've got negative 2t dt. But here, notice I just have this part of it. I need a negative 2 out there. So what do? We multiply by negative 2, and then that means we have to come out and multiply by the reciprocal. So this is the same thing as multiplying by 1. Okay, so now let's make our substitutions. So I've got s is equal to negative 1/2 times the integral. Now the 9 minus t squared, that's going to be replaced with u, so that's u to the 1/2. And then the negative 2t dt, see, the negative 2t dt, I'm replacing that with du. And so let's come up here and integrate this. So that's going to be s is equal to negative 1/2. And so that's going to be u. I'm going to add 1. So 1/2 plus 1 is 3/2. Multiply by the reciprocal of the new exponent plus c. And so this is going to be s is equal to negative 1/3 u to the 3/2, but I need to get it back in terms of t. So I'm going to plug this back in for u. So that's going to be 9 minus t squared to the 3/2 plus c. Now let me erase this. We got a little more work to do. Now, they've given us enough information to figure out what c is. Say they tell us s is equal to 0 when t is equal to 0. So I'm going to replace s and t with 0. And so 0 is equal to negative 1/3 times 9 minus 0 squared to the 3/2 plus c. All right. And so this is going to be 0 equals. So that's going to be negative 1/3 times 9 to the 3/2 plus c. And so 0 is equal to negative 1/3 times. All right, so let's look and see what we get here. So remember, 9 to the 3/2, that's the same thing as the square root of 9 cubed, which that's square root of 9 is 3. 3 cubed is 27. So that's 27 plus c. 0 equals negative 9 plus c. So c is equal to 9. And remember, this was my antiderivative right here. And I figured out, found what c was. And so my final answer is, let's see, let's erase this and write it up underneath. So that's going to be s is equal to negative 1/3 times 9 minus t squared to the 3/2. And then we got c was 9. So that's plus 9. And there's my answer. Okay. All right. So let's look at another problem that I wanted to add. And let's see. All right, let's do this. The integral of 2x squared over the square root of 2x cubed plus 1 dx. All right, let's look at this one. Now, do I have something in parentheses raised to a power? Yes, I do. I have 2x squared over 2x cubed plus 1 to the 1/2 dx. All right. All right. Now, let's look at this. Let's take the derivative of what's inside the parentheses. Remember, isn't that what we've been doing throughout the whole video? Let u equal what's inside the parentheses. And then we take the derivative of that. Well, what's the derivative of 2x cubed plus 1? That would be what? 6x squared. That doesn't match this, does it? You see that? So I've got a 2 in front. And if you notice in the other problems, okay, I'm going to explain this 2 different ways and tell you which way I think you ought to do it, because it'll make it easier on other problems. But let's just go back up here where we use the u-substitution. Now, I'm telling you, this is very, very important you get this. All right, let's see. Wait a minute, where are we? Here we go. So remember, when I let u equal this in here and I took the derivative, it matched exactly. You see that? The 2x dx matched exactly. Here, it didn't match. You see that? I needed to multiply by 3. I had a 1 in front of the x squared term, but I needed a 3, so I just multiplied by 3. And then, well, that one was not a u-substitution, but this one was. This one, when I let u equal, let's see, where is it? Did I erase it? Yeah. But remember, if you remember, I let u equal 9 minus t squared, and so du was negative 2t dt. See, it didn't match this out here, but there was a 1 in front of the t, so I just multiplied by negative 2, and then went outside and multiplied by negative 1/2. Okay? And so now that gets us back to this problem. I'm going to put a little line here. That gets us back to this problem. See, there's not a 1 in front of the x squared. You see that? So let me explain it one way, and this is not the way that I'm going to do it. You can do it this way, and if you understand it and see it, it's perfectly fine. But let me just show you this I think it'll make it easier overall. So first, let me explain it the way we're not going to work it, but which is perfectly acceptable. So if you let u equal 2x cubed plus 1, you get du is equal to 6x squared dx. You see that? But notice here I got 2x squared dx, but I need 6x squared dx. So actually what I would do is multiply by 3, because 3 times 2 would give me the 6. You see that? And then I would come out here and multiply by 1/3. Okay? And if you understand that, by all means, work it like that if it's easy for you. Nothing wrong with that. But let me show you this. So when I take the derivative of this, and I notice that this number does not match this number, what I like to do is go ahead and rewrite it one more time. And pull that 2 out. So I've got x squared over 2x cubed plus 1 to the 1/2 dx. Just pull the 2 out because it doesn't match. See, the coefficient up here does not match this coefficient. So I'm just going to take this one, pull it outside the integral symbol. And so now when I'm looking in here, notice I have x squared dx. X squared dx, I need a 6. So I'm going to multiply by 6, and then I'm going to come out here and divide by 6. You see that? Look, I still get my 1/3. Okay? I hope you see what I did. And I know you might be thinking, well, you didn't have to pull the 2 out because you could have just multiplied by 3. Okay? But let me ask you this. The reason I'm showing you just to pull this number out, the reason I'm showing you that is, what if this number were a 5? What are you going to multiply to 5 to get a 6? Well, you would have to multiply by a fraction. You see what I'm talking about? Or if in front of the x squared, what if in front of the x squared was 7/3? You see that? If instead of the 2 right here, what if that was 7/3? I'm going to write it in a different color. What if that was 7/3 x squared? Okay, so what are you going to multiply to this to get a 6? I mean, you can figure out what you need to do, but do you see how it's much more difficult? So, like if that was a 7/3, just pull the 7/3 out, and then you know, well, I just got to multiply by 6. That's why I'm showing you just pull the 2 out. I hope all that makes sense. Now, of course, on this problem, no, it's not any more difficult if you leave the 2 in there because we know 2 times 3 is 6. That's an easy one. But what I'm saying is for when it's a number that's not so easy to say, okay, what can I multiply to get to that number to get 6? That's why I'm saying if it's like that, just pull that out and then multiply by the 6, divide by 6. Okay? All right, so let's go ahead and make our substitutions. So that's going to be what? You see there, I still got 2/6 is 1/3. That's what we had when we didn't pull the 2 out. You see, you're still going to get the same thing. And so, all right, so look at this. So I got the 6x squared dx, 6x squared dx. That's going to be replaced with du. So let's just put the du there. And then the 2x cubed plus 1, 2x cubed plus 1, that's going to be replaced with u. So that's u to the 1/2. All right, but still, we're not ready to integrate this because we don't have a variable raised to a power. I mean, we do, but it's in the denominator. And what do we do when it's in the denominator? Well, we move it up to the numerator. And now we can apply that rule. And so that's going to be 1/3. That's going to be u. We got -1/2 plus 1 is 1/2. Multiply by the reciprocal of the new exponent plus c. And so that's going to give us 2/3 times. And in the place of u, I'm going to put the 2x cubed plus 1 to the 1/2 plus c. And, you know, you can leave it like this. As far as my students go, you can leave it like that. Some teachers, they may want you to put it in this form. Write it back as a square root. I don't know. Just ask your teacher how they want the answer. But as far as my students go, you can leave it like that. But yeah, that's what I wanted to show you there. That if when you take that derivative and that number for, that's with your dx, if that number doesn't match, just pull the number out. Just makes it easier. But as I explained, you don't have to. It just makes it easier in certain circumstances. All right. So that's all of this video, and I'm telling you, it's so important that you understand the u-substitution that we did. And in the in videos after this, we're going to do more u-substitution. So I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next one. Later.